Human evolution is a journey that spans millions of years. In this video, we will be tracing the transformative path from the Big Bang to the remarkably complex beings we are today. The process of change and adaptation encompassing a myriad of biological, cultural, and cognitive development, shaping the very essence of what it means to be human. From humble beginnings as bipedal hominins in Africa to the globally dispersed and technologically advanced Homo sapiens we recognize today, the story of human evolution is a testament to tenacity of life and ceaseless quest for survival and improvement. Join us on a voyage through time, unraveling the threads of genetic heritage, behavioral evolution, and extraordinary twists and turns that have defined the remarkable odyssey that is called humanity. Hello and welcome back to the podcast, bros. As always, it's me, Avisraj Sumargi, and today we are going to be talking about evolution. And this is a more generic term of evolution that we're going to be talking about. It's the evolution of the universe as we know it. It's also the evolution of human and the different steps that we undertook to get here as Homo sapiens that we know today, right? So let's take it from the very, very, very top. And then we have to touch on the Big Bang. 13.8 billion years ago, the universe started from a very, very small, hot and dense point, right? That rapidly expanded, that now we know as the Big Bang. And the origin of space, time, and matter comes from the Big Bang, right? So once the Big Bang happened, all we know from that period is that it was a pool of hot atoms and molecules that were scattered all over the universe, right? And during this period, from almost to 380,000 years, it is known as the cosmic dark ages. And the reason it's called the cosmic dark ages is because it took time for the matter to cool down and start dancing together because of the gravity. So we do not have any light or radiation that we can track back to this period. Hence, we know this period to be known as the cosmic dark ages. But once this cosmic dark age is finished, from 380,000 years, we see semblance of light throughout the time, right? And we know that the first formation of galaxies and stars started to take place from that 380,000 years to almost 100 million to 150 million years. And these were the very early stars, still getting used to the environment that they were in, still getting used to the gravity pushing them together and formation of whether it be planets or stars themselves, right? And during this period, it was a very, very violent period. So some of the stars would be formed and it would collapse given that there wasn't enough matter or atoms in them. So it would, because of the nuclear fusion, it would be violent coming together as well as breaking down, right? So supernovas would form and trying to become a sun, but they would midway through the process fail and turn into a supernova that we can still track now, right? Which is very, very interesting. And all of this can be tracked because of the Hubble telescope and all the other telescopes that are out there now in the Earth's atmosphere that are very, very precise in their findings, right? But once the planets and the stars started to form, now we come to now that became a common thing in the environment, in the universe and universal environment. And by the way, you guys have to take into account that the things that we are talking about right now, these are things, though it sounds really not that far ago, because 13.8 billion, the billion number sounds big, but 13.8 sounds really small. But these things took place over billions and billions of years, over a very, very long time, right? So it also came to a stasis point where now it is a very common thing for galaxies to form or stars to form and all that, and even some of them to collapse into one another, right? But the formation of planetary systems started to take place. Our planetary solar system started to take place 4.6 billion years ago. And during this period, again, another solar nebula was compressed with gas, dust, and heat, right? And it collapsed into one another for a long period of time, but eventually it started to form the sun that we know from our solar system. And once the sun was formed, then it started to, because of its gravitational pull, it started to form another planets, and other planets started to form around them. And now we know the solar system as we know today with the 8 planets. Pluto is not counted, by the way. So sorry for the Pluto fans out there. But the 8 planets that we know it, and the celestial bodies like moons and all that started to form around that period. Now, that is the evolution of the universe. But now let's talk about biological evolution. So one would think that it took time for, the planet to start having life and all that. But once the Earth was formed, right, it was a hot ball that was like, because you have to understand that these are super violent phenomenons when planets or stars are forming. So it is just celestial bodies banging into a bigger body, and some of the debris might stay on, some of the debris might float away and all that. And the Earth was very, very hot. But once the cooling process started, then life almost instantaneously formed, right? Also, it is believed that, and this is a term that we or the scientists themselves have coined, the Goldilocks zone, right? And if people are familiar with the Goldilocks story, then Earth happens to form in a space in the solar system where it's not too far from the sun, it's not too close to the sun, right? So this environment created opportunity for water to form, carbon dioxide, nitrogen and oxygen and all these other different things. And even now, when we are tracking some of the other planets in the solar system or the universe, one of the first things that we try to find out is water, right? Because it is a very common fact that if there is water anywhere in any planet, then there is going to be single-celled organism. It doesn't have to be complex life forms. We cannot expect aliens or something like that are super smart than us. But complex and smart life forms aside, single-celled organisms can still form if there is evidence of water in any planets, right? So as the Earth started to cool down 600 million years later, which is at the start of 4 billion years ago, we have started to find evidence of single-celled organism life in the Earth, right? And that is a long time ago, by the way. It's relatively smaller given comparison to the universe formation or the Big Bang, but it is a long time ago. And during this period, the evidence that we find are generally from the Western Greenlands and Western Australia of single-celled organisms that were living and thriving in the Earth's environment, right? And there is also the concept of last universal common ancestor. So it is believed that all species that are formed on Earth came from a single-cell organism, a common single-cell organism that diverse enough into multicellular organism that all these species started to get formed. But that is another very interesting thing, that like if we really turn back time and boil it down, then we all can be traced back to one species. So the question is begged, are we all animals? But that's a joke on my end. But anyways, so after the single-cell organisms started to form, then it took a while for the single-cell organisms to be adaptive enough that they go into multicellular organisms, right? And that period is traced back to 1 billion to 600 million years ago. And during this period, there are evidence that suggests that life started to evolve, right, into multicellular organisms. And after that, almost 60 million years after that, because you guys have to take into account as well that multicellular organisms are still 2 cells joined together, right? Once the process of that started, it accelerated really quickly. So now you have to take into consideration that it took almost 600 million for single cell to form, right? It took almost 4 billion years for multicell to form. But in 60 million years, then came the Cambrian expansion. And this is very fascinating because once the multicellular organism started to function properly, then 2 cell became 3 cell, 4 cell, now billions of cells combined together. And once the Cambrian expansion hit 60 million years later, after the evolution of multicellular organisms, then we see a burst of all these different species that came into being, right? Most of the species that we know of today got their foundation then, right? And now I'll take you through some of the species that we all love, and that's the age of dinosaur, right? It took 200 plus years, 200 million years for the formation of dinosaurs to come. But once the dinosaur came into existence, right, which was 252 million years ago, they were the rulers of Earth for almost 200 million years. I know we humans take pride in the fact that civilization has existed for around 10,000 years or 11,000 years and whatnot. But 200 million years of just superiority? Oh my days, I don't know if we'll be ever able to match that. But the dinosaurs came into being, and we all know how the dinosaurs became extinct. Universal cataclysms of meteor shower that created such an inhospitable environment that the dinosaurs could not survive. And the theory of evolution will come there, right? Survival of the fittest. So the species that is most adaptable in any environment, that is a species that will always thrive, irrespective of whatever space the universe might be in, right? So the dinosaurs were not able to adapt, and eventually the inhospitable environment slowly but steadily started to kill them down. And now all that we have of the dinosaurs are chickens. So think about that, right? But once the dinosaurs were gone, and then it took about 1 million years for the Earth to again go back to the stasis of itself. Once that happened, then comes the rise of mammals, and we Homo sapiens are also mammals, right? So this was the age of early primates, all these different things that you can think of, all these different species. And of course, over time, these species changed, like evolution always does, right? Like different environments is created. Given that different environment, different species has to come around and adapt. And once you adapt, the DNA changes, the gene sequencing changes. And once the gene sequencing changes, then you are evolving, right? So that's basically it. But it from 65 million years ago to 23 million years ago was the age of rise of mammals. And once that happened, then more different kinds of species started to form on Earth. And around 7 million to 2 million years ago was the humanoid evolution. And this is the age where we can first trace the common ancestors that we have with the apes, right? So around 7 million to 2 million years ago. And that is the emergence of the Homo genome that we know, Homo sapiens, Homo genus that we know today, right? So now, what were some of the different kind of ape evolution that we had to go through before we came here? So one of the first species that we can still track back with evidence is the Homo habilis, right? And these are believed to be around 2.1 to 1.5 million years ago. So these species, and the reason we are connected to them are we can find tools that they used, right? We can find evidence of intelligent way of thinking, communal way of behaving, so that they all can thrive equally and more better rather than single, right? So being single and trying to hunt and all that. So Homo habilis was one of the first Homo genus species that we can relate to Homo sapiens. Then came the Homo erectus, right? And the Homo erectus is a species that is believed to be around from 1.9 million years to 140,000 years ago. And this is one of the most transformative evolution step that human Homo genus species made. Why? The reason being, these were bipedals. So basically, they were able to stand on two legs. They did not have to rely on all four of their limbs to walk around, go for hunts and all that. They had to rely on two legs. They could walk, they could run, they could do all these different things, and they could be much more tactical in climbing, doing all these different things. If you look to some of the chimpanzees, they have a very stiff back, right? And they cannot stand. But the Homo erectus was one of the species that had flexible backs. Bones were much more separated and defined, because of which they were more flexible and all that. So that is one of the most monumental step that the human evolution took, right? After that, we can track some of the other species, and these are fairly recent, right? So we can go to the Homo neanderthals. Homo neanderthals, these are the species that were majorly found in Europe and Asia, right? And they lived from 400,000 to 40,000 years ago. So and they were typically more favored. They were more resilient in cold climates or cold temperatures, right? So they are believed to be one of the better variant of the Homo genus, right? They were able to hunt in packs, they were able to create tools, they were smart. But there is also another species around the same time that is from 100,000 years to 60,000 years ago, and I'm going to butcher the name, by the way, but it's Homo floresiensis, right? And they are also known as the hobbits, right? And the reason they are known as the hobbits are they were really small in stature, and they were generally found in the Indonesian Flores island. So there's tons of evidence that we have found about them. And they're also known as Denisovans, easily, so that it's easier to preface them. But they are also believed to be species that diversified from the Homo erectus, Homo neanderthal species, and as they separated over time, their genes started to evolve, and they were smaller and diminutive, whereas the Neanderthals are believed to be tall and really strong in their structure, right? And after all that comes the most smartest of them all, and that's the Homo sapiens. And it is believed, right, and it's just a theory, we don't know for sure, that Homo sapiens kind of drove Neanderthals and the Homo floresiensis out of existence, because even now we see that there is like cultural war and all that, and all tribal war, right? So even in the Homo sapiens and Homo neanderthals, there were tribal things that happened, and there were wars, and maybe a lot of them died. But there's another theory that comes, right? And the other theory is, and it's not a theory, we can see the evidence of it. It's not very well discussed all over the scientific community, but the theory that comes is that they could breed with one another, whether it be Homo neanderthals, whether it be Homo floresiensis, right? They could breed with one another and Homo sapiens. So because of this, we got the origins of different kind of bodies and different kind of shapes and different kind of eye colors, irises, right? And different skin colors and all that. But the reason this is not discussed a lot is because then this leans in more to the racial arguments and points that was made over time, especially in the 18th and 19th century, right? So that's why this is not openly discussed. But I am of the belief system that Homo sapiens and Homo neanderthals, they mated, and that led to the origins of the Scandinavian Viking kind of people that were very strong and tall in their structure. And if you go to the Asian side of the pond, then it is like the Asians are a little bit smaller in stature. Even me, I'm an Asian, so there's a mix here somewhere. I don't know what it is, but the theories suggest that this has to be the case, right? That the sapiens and different other homogeneous species mated with one another, and that led to the diversification and offsprings of different colors and this and that and all. Not trying to be racist here, by the way, but that the theory suggests that, right? And over time, and the reason it is believed that the Homo sapiens are much more smarter and all that is because the Homo sapiens, though smaller in stature than the Neanderthals, were much more advanced in the way they could cognitively process things, right? So yeah, that's pretty much it. That's why it is believed that the Homo sapiens are much more adaptive, because like I said, Neanderthals much more acclimatized to the cold environment, but Homo sapiens could adapt in cold, adapt in really hot, really cold. There is a degree of variance there. So that's why, coming back to the survival of the fittest, right? So that's pretty much everything about how we transformed from apes. And by the way, I haven't mentioned this so far, and that's stupid on my behalf, but Africa is the place of origin, which is believed to be the place where all these different homogeneous species formed, right? So that is why, and it is believed that from Africa, all these species travel to different places, and we get all these diverse, different kind of species intermixed with one another, right? So that's pretty much everything on the evolution side of human, coming from a single cell organism, right? And before that, evolution of the universe coming from a Big Bang, right? So when did all of this come into a head-on collision and it became a natural thing that, oh, theory of evolution is true? Before the publication of Charles Darwin's book, everyone believed that God created humans, and God created humans different from other species, and we are not supposed to be animals and all that, right? But then comes this genius in the 19th century, Charles Darwin, who was born in 1809 and died in 1882. So completely lived in the 19th century, and you guys also have to take into consideration that this is a period of ideas that are being expanded from the Renaissance, right? So Renaissance was the period around 14th and 15th century where people started to get creative with their arts. We see Copernicus and Galileo coming. We see Newton coming. We see all these different people coming and trying to expand on the universe and all that. And this was the chemical side, or this was the physics side of it. But Charles Darwin was the first guy that evolved the idea, and as it seems to be the theme of today's episode, evolution evolved the biology and medicine as we know today. So Charles Darwin, he was from a wealthy family and all that, and he was in naturalist and a biologist, and he had an inkling for these things from early on. He used to collect specimens when he was a child, this, that, and all. And when as he was growing up, he was appointed as the naturalist for the HMS Her Majesty's Beagle. So this was a ship that was traveling Europe and all these different places. And during this 5 years journey, the Beagle stopped in Galapagos Islands, right? And this is where Charles Darwin's curiosity really spiked, because he saw different kind of turtles, and for the cooler environment he saw turtles that did not have long necks, but whereas some of the other turtles in the Galapagos, they had like abnormally long necks, right? And then he started to really hone into this. So like it took him 20 years to really come up with the theory of evolution. Why? He was supposed to be a very smart man, right? So he knew that the pitfall of a half-baked theory would get him killed, right? We've seen this example with Copernicus, Galileo, and all these different people, because he was pushing against the norm, right? He was pushing against God himself, right? So he had to be very careful. But once he had the theory down and like he started experimenting with different species, opening them up and all that and all, he came up with the theory of natural selection and natural selection. So, and the other thing that really piqued his interest was during this period, this was also the period of mixed breeding of dogs, right? So all these species of different dogs that you see today, the aristocrats from Europe at that period, they wanted all these different species of dogs. Someone wanted a smaller dog, someone wanted massive, like mastiffs kind of dogs and all that and all. So he started to think that like if artificial, selection still breeds different kind of species, then there like natural selection had to have taken place for all these different kind of people to have formed and all these different species to have existed, right? Whether it doesn't have to be just humans, evolution goes all the way through, right? So then he started to really hone in into the natural selection, and I forget the other guy's name, but there was another scientist at that period who kind of came to Charles Darwin, and he was like, okay, I know you're developing this theory, and given my research, I have also come to the same conclusion. So then Charles Darwin felt strong enough that he was like, okay, I'm going to publish this. And then he published the book on natural selection, and then the whole history of evolution and biology and the way we think about life on planet as we know it completely changed. And it took a while for all the different factions of community in the academic forum to accept his theory, but eventually there was no, it was irrefutable, and now it is just normally known. And Charles Darwin's theory of evolution is the most influential scientific theory ever posted, right? It forms the cornerstone for modern biology, explaining the unity and diversity of life. And Darwin's work laid the groundwork for subsequent advancement in genetics, right, paleontology, and various branches of biology. So not only did Charles Darwin theory push the limits of human biology and medicine and all that, it also pushed the idea of how could different plants mingle together and form something else. How could different species mingle together and form something else, right? So it was so overly encompassing that now Charles Darwin is known as the father of evolution, right? So yeah, that's pretty much everything to get you covered on evolution as a whole, whether it be the evolution of the universe, evolution of single cell organisms, and even human species. And the father of all of this, Charles Darwin, whose theory finally broke the norm and created this massive renaissance in science as well. So yeah, that's pretty much it on the evolution. And like I've always said in all of my previous videos as well, what we do here in the Podcast Bros is we're not trying to give you everything here, right? We're not trying to explain everything to you here. We are just giving you the first steps of everything, so that if it piques your curiosity, then you can go and find more about it on yourself, right? So that's why in this video, it's evolution, yes, but it's not just about Charles Darwin, or it's not just about humans, but it's evolution as a whole, whether it be universe or like carbon-based life. So that's pretty much it on my end. If you have any questions, please feel free to comment on the video below. And yeah, thank you so much for tuning in again, and hope you guys really enjoyed this video, and I'll see you guys in the next one. Peace.